Hello, so in this video we're going to have a look at some more solving equations, and I'm going to look at a few more slightly trickier equations. Let's have a look. I've got a plus 6 equals 7a take away 12. Well, are you happy? I've got the a's kind of spread on both sides. Now, it doesn't matter, like at the moment, I just want to get them all on the same side. It doesn't matter which term I take on which side, as long as I just end up with all of the a terms together on one side. Let's have a look at this then. So I've got a plus 6 and a 7a might take away 12. I've got two options. Either I could take away a from both sides, and then I'd be left with just a 6 on the left-hand side, and I'll end up with a 6a on the right-hand side, take away 12. Okay, because you're happy 7a take away a is 6a, and I'm left with a minus 12 just hanging around at the end there. If I wanted to take the 7a on the other side, then all I'd do is I'd just take away 7a from both sides, and I'd get exactly the same kind of thing, and I just solve it from there. But let's deal with this for the time being. Okay, so here, this is basically just saying I take some number, I times it by 6, I take away 12, and I get 6. So therefore, if I work my way backwards, I should have to add 12 to both sides. Just think about that chain I was doing in that last video. In fact, you can write it out if you want to. So I add 12 to both sides, so I just end up with 18 on this side. And on the right-hand side, I'm just left with 6a, because the minus 12, the plus 12, they disappear. So now what I need to do is I need to get rid of this 6. So my chain tells me I should divide both sides by 6. So if I divide both sides by 6, on the left-hand side, I'm left with 3, and on the right-hand side, I'm just left with an a. And then just for argument's sake, I'm just going to write this as a equals 3, because to my mind that looks nicer. It's much nicer to say a equals 3 than 3 equals a, but hey, whatever you fancy. Now let's have a look at the next one. So I have 5 take away 2b equals 11 plus 6b. Now it doesn't matter which one I take on which side. So I need to get all the b's together on the same side. I'm going to get all of the b's on the right-hand side, just because I can. So let's have a look. I'm going to do that by adding 2b to both sides. Are you happy? Because at the moment I've got a minus 2b, so in order to get rid of it, I have to add 2b to both sides. Okay, so on the left-hand side, I'm just left with 5. And on the right-hand side, I'm left with, well, 11 plus, what's 6b plus 2b? It's 8b. So I'm left like this. And then again, I can write my chain out and I can work my way backwards along the chain. But if you do that, it should tell you to take away 11 from both sides. So if I take away 11 from both sides, I'm left with, well, what's 5 take away 11? It's negative 6. And on the right-hand side, 11 take away 11 is gone. I'm just left with an 8b. And then finally, to finish this off, I should divide both sides by 8. Now again, you can sit there and you can stress, what is negative 6 divided by 8? Well, I'm just going to write it as negative 6 divided by 8. And of course, the whole thing's negative, so I'll just pull the negative out the front there. And that equals b. Okay, I could simplify this slightly. So first of all, I'm going to write it as b equals negative 6/8. What is negative 6/8 cancelled down? Well, it's negative 3/4. Just like that. And that's exactly how I would leave it. Okay, so have a look at this next one then. This one's a little bit more awkward because there's brackets and there's squares and things going on. Don't worry about it, okay? Just literally get rid of the brackets and then you can work with it a little bit more easily. So let's expand this bracket out. So remember c times c, which makes c squared, and then c times negative 4, which makes negative 4c. And that equals, well, the right-hand side hasn't changed one bit, okay? So all I'm doing there is I'm making it look like something that I have seen before. And I'm doing that by getting rid of the brackets, expanding them out. I know how to deal with that, all right? Okay, so now I've got c squared negative 4c equals c squared plus 12. Well, first things first, I want to get all of the c terms on the same side. I think there's an obvious choice here. Because there's only one c term, c squared term on that side, and there's two c's on that side, I think it's less work to take that c squared term on the other side. So I do that, we'll think about it. At the moment, it's a plus c squared. So in order to get rid of it, I have to take away c squared from both sides. Now let's have a think. Oh, that's quite handy actually, because I have c squared take away 4c, but if I take away c squared, are you happy the c squareds are going to cancel each other out? So I'll just be left with a negative 4c on the left-hand side. Then the right-hand side, well, the c squared term is gone, I'm just left with 12. Now here it's awkward, okay? Do it in stages then, because the negative's there, right? Do it in stages. So what I'm literally going to do here is I'm going to divide both sides by 4. Okay, pretend like the negative isn't there. So it'll just be like negative c and divide both sides by 4. I end up with 3 on the right hand side. And if you ever get to this point, you're like, oh, what do I do here? I don't know how to finish it off. It's really easy, okay? Negative some number equals 3, well then that number must be negative 3, mustn't it? What you've literally done there is divided both sides by negative 1, if you think about it formally, or you can think about it logically, because the negative of negative 3 makes me 3. Either way works.